All right. All right. So let's do this. Let's do a single link list. So we'll have just a manager here, just a holder. So this is the holder. And let's have a node with just next. And let's give ourselves key 0 and key 1. And the goal is we're going to fill this thing up. So this is just a total nonsensical structure. And what we're going to do is I'm going to sit there and say, add, a key. So we'll add a key. Okay. And then our structure is going to look like this underneath. So we create the first node, and we'll put this key in there, A, right? And this other one's blank. And we turn on add again, a key B, and now here's B, and we add again, key C, and then what we'll wind up doing is doing another next, and create a whole nother bucket, and then add C. And we do add key D, and D goes there, and then we add key E, we're out of space. So then we add E here. Okay, does that make sense?
Yeah.
I just wanted something that's kind of different. It's not going to be a lot of the same code. Let's give that a try. Nice if I'm in the right class. Has been okay, cool. All right, so hopefully this will fire up. So I don't know about you guys, but I'm constantly coding. So that's one thing. You get better just by doing it more. All right. All right, so here's our code. And the thing is, just stop me and ask questions whenever. This is really for you. All right, so we're on T. Let's just make sure it's runs. All right. I hate that screen that comes on there, so I'm just gonna put a breakpoint here. And then oops. All right, so we'll get to the screen. I'm just going to shrink it so I don't see it all the time. All right. All right, so let's start. All right, so the first thing I do almost always is just right click and create. When you're prototyping stuff up, so I just create a diagram. And it's going here and it says diagram. So I just create a diagram. And I'm not going to be using marker board. I'm just going to use this, right? So we look at this. Okay, so what do we want to call our holder? So let's call our holder something. I don't know. Do you want to just call it holder? All right, let's call the holder. Right. So I'm just a prototype a holder. Right. So boom here. Add new item class holder. Right. Delete all this crap because you don't need it, and put in here diagnostics. All right. So now so here goes to this, and we just drag holder over. Pop. Right now, so what are we going to call this little box here? Let's call it
a node. A node.
Yeah, the problem is we keep using node and we keep using terms that are generic. Let's do this differently.
A cell maybe.
So let's do it this way. How about this? What if we do this? We call this is a briefcase. And then this is a person. So a person holds, and in some cases they might have to hold multiple briefcases. Okay, so this way we humanize it a little bit. Right. So let's go back here and rename this briefcase. I mean person. Okay. Now, and let's call it case. Right, and then the person will have a pointer. Case P0 head. P0 meaning pointer, 0 meaning, or O meaning owns, so pointer owns the head of it. And now, boom. Okay, now on our case, let's kind of keep it simple right now. This has public int key1, key 0, public. Right. Now we need to have this in a linked list. Let's put the links just right into it. Public case P next. All right. So this is what we got so far. And then this would kind of go and point to its, the next one, next one, next one, next one. All right. So so now let's populate this. So person new person, right? And debug.assert, and everybody thinks like, oh, I don't need to do this stuff. You have to do these debug asserts because this is going to be your lifeline. When you screw something up, this is what's going to catch. So assertions essentially anytime you have it, if the code can go wrong because of something that happens, assert that it's you're in a good state. So this new may fail. So we're going to assert that this is not null, because if it's null, the thing explodes later. So if you go person, p person dot blah blah blah, and the pointer is null, the thing will explode. So let's catch it right when we created it. All right. So now, so quick compile and run. Okay, so all right. So now let's go into this. Let's put a little print statement in here. So public person. All right. So now I'm going to debug that right line person. This and get hash code, and we'll treat hash code as a unique identifier. Okay. And there we go. The thing was constructed, and here's this unique number. All right. So what we're going to do in here? Well, once we're inside the person, we're going to create. We should initialize the p head. So this always, p0 person. That's our p. What am I not getting autocomplete? Oh, I'm not in the class. Sorry. This dot p0 head equals null. We'll leave that empty on purpose. So now, we're going to create a case. Or we're going to add a key. So we're going to go p person add a key. Over here, right, we can manage public enums. And then public void add a magic happens in there. Okay. So now we want to add this to the person dot key dot a. All right. So far, haven't done much, but we can go in here and put a breakpoint and kind of step into it. I'm much more of a believer in prints because you can run fast action with prints. So here's our print. Pointer's null. Add. It goes in there, adds a key. We can check the key value by hovering over it. All right. And for those who just entered on here and into this thing, all I'm doing is coding. If you have something you want me to do differently, but I really thought it was probably a good idea to just watch a little bit of coding. All right, what are we gonna do? We're gonna add. So if p this p head is equal to null, p add a case, right? Else check the existing case. All right, so it's empty. So review is case temp equals new case. Debug dot assert p temp equal to null. That's a good pointer now. So this dot p0 equals p temp. right, so now we should be entering into this code here. Go into it, it's empty, create a new case, and then associate it. Okay, so now what's in our case? We need to define our case. So let's do that. Data. So public case. This, all right, so what do we, how do we want to initialize this? Well, we need, whatever we do in our constructor, we have to make sure we initialize all the data. That's just good practice. So this dot next. So a trick I tend to do is I just tend to copy it over. So now I don't miss a variable, right? And and then alt, and I start kind of aligning this, and then I can just go boom, this, that, right? And then there's me null. What's there? Oops. Right, so we need to have it equal to a key. So let's add a key as a default variable. Empty. All right, so in enumerations, you don't put a comma there. It's the last comma here that has to be a real value. Don't leave with a trailing comma. All right, so now here, person dot owns dot key dot. Right. And then now this should not be an int. This should be a type key. Right. All right. So now we should probably have a print statement. Public void dump. You can use the word print. I just like the word dump because it's old thrashing your registers would be a core dump to the screen. All right, so here would be debug that right line, and then it'd be case, give its address. Oops. This dot get hash, and then what do we have here? We have the debug, right? Next. P0 next, okay. And then debug. Most people do not do print statements. I can't tell you how useful they are. They're hugely useful. And it takes a little bit. It's not easy at first, but once you kind of start doing it, it's the little bit of work you do here pays off. So this is going to be key. I got a little bit of Spilkis. What's this? Person not found. Person. Okay, let's go person. public, namespace sandbox, case, sandbox, public. Alias in person. Person key. That's the same person key. Okay, see what I did wrong? So warning order. It's from the severe. This person. I am spinning on this. Wow, I'm hung up right now. So news. Oh, double colon. Sorry. C++. It's that. Oops. There you go. All right. All right. So let's see where we're at. So from here, go into it. Blah blah blah. Call a case. Think. There's a new case. Right. So now, right here, let's just do a quick print. P temp that. That seems to be cool, right? Empty, empty, and then this should be next. Didn't print anything. Next. It's a null, so it's not printing it. Right, so make this like a little bit more pretty. If this dot p next equals null, something clever. So oh, how did I print twice? Oh, it's down here too. Okay. There you go. All right, so that should look all pretty now. Yeah. Okay. So now we're off to the races. So now all we did here is add a node. We haven't added the key yet. So this is just prep. So this is like find the case. All right, so we're assuming all that works. Now at this point here, okay, cool. The case. Let's see if we give ourselves a name here. Case start p case equals null. And then this right here should be this p case equals p. And then what we're going to do is just check this. So we'll do that insert. Now here's where we do the add. Right, so if p case dot k0 is equal to empty, we're going to add it here. So p case p 0 equals okay. If and p case key on else something bad's happened. We should not be in this case here. So debug dot assert false. Okay. So here we are here. It goes through here and boom, 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 creates this, finds a case. Case is not null. First one's empty. Assign it, cool, and leave. All right. So what we want now is probably a way to start seeing our code. So we want public void dump. This is going to be on the person. So this is going to say case p temp equals this dot p head, right? While p temp is not equal to null. Something clever. P temp equals p temp dot p next. Iterate through it. And it becomes p temp dot delegate that guy. Pretty statement here. Right line. Person. End it with space. I don't like that one. Okay. All right, so that should give us, I didn't call it yet. So let's go back to the calling. We added one. Let's see what she looks like. P person dot. There it is right here. All right, so here, let's add a new line at the end of this. I tend to always do new lines as literally, I do one statement per thing. Oh, right line. That's cool. No. Right. Then dump this. This is all kind of leading astray. So this is a dump. Right. And then the case should be indented in our level. The case. So let's do a slash t /t. Now, you might think I'm taking too much time on the prints, but this stuff kind of starts paying dividends very quickly. There we go. So now I like that. I like kind of what it says. All right. So now let's see. Let's add another one. Program. Let's add another one. Now I just go dump. I can see it incrementally go. Blammo, right? All right, so it's yelling at it here. Key is empty. If key is equal to empty, do this. So why am I getting a complaint? Because P case is null. That's true. Should have thrown an assert. Run this again. Break out. And it throws an assert, so you got to retry. Boom, it drops down a line. It says, "Hey, this case is P," which means something up here is wrong, right? So what happened is the first time it went through, it went into this code. So we're in the else. So else, this was it P case equals this dot P head. Okay. So that's gonna be wrong. We have to fix this more, but that should get us through this part. Cool. All right. So now we can see the first time A, next time B, right? So we're starting to cook with gas. So now C. And now it's going to yell at me because it says, okay, you messed up, right? So what this means here is that my case is filled. I need to find another case, right? So what I should do is this. Create a function, a helper function, to check that. So private bool node case full. But actually, why am I asking case? I should really do it in the case function, not here, because the case function knows what's going on. So what we're doing here is full. And what this is going to do is, all right, what it's going to do here is going to check to see the two keys. So this that key is not empty. And same thing again, but for the other key. So they both have to be not empty, right? So if they're both not empty, it's full. Else is false. So this says if this key is not empty and this key is not empty, they're both being used. So therefore, it is true. The full is true. If one of these are empty, then it's false. So I always set my variable to a bad default, reset it, and then return the variable. Do not do multiple returns. Always do one return out of your function. The reason for that is that now I just do one print statement here. I know what's happening. There's no way the program could have escaped without going through that function or that pinch off point. Right, so here's this is full. Right, so first thing I'm going to do now is after I want to find the case. Once there's a P case is full. Okay, so public. It should be public here. Right, and it should be false. So let's put in assert debug that. Assert. It should be full. Should equal false. If it doesn't, don't continue on. Something's bad, right? So now when I do this, it should yell at me at this line. And it does. It yells at me that line as expected. All right. So at this point here, sometimes you get into bugs and it just tripped. When it throws an assert, what's awesome about assert is you can go to this thing called call stack and you can see how did I get here? I called this program and then I called that program. So you can kind of see where were you in each of these steps. So I started off here, then it calls that function. Now I'm in this, and this is where the error happened. So no matter if you go 3, 4, 5 deep, the call stack will help us out of that. All right, so our problem right now is this thing, find a case. So let's kick the can and make this useful for us. Let's say, let's sit there and say find, so private case of return, priv, find empty case. Right? So what we're going to do is put our logic in here, try to find an empty case. So instead of loading this function out, we're going to kind of move this stuff over into here and start beating the crap out of it there. Right. So here's our return pk case p case equals no. Right. Then when we leave the function, we'll point down here, we'll return p case, right? But that p case better be valid. So let's put the debug right there. Now we start off. Is the head open? Yes or no? So we'll go with this. Is the head empty? Well, here's the head empty. We can do this, and this thing will fall out, and everything's cool. Else, the head is something not null, so that's good. Now we need to check this. So we'll do case p temp equals this dot p head p temp null. Right. And it's p temp equals p temp dot p next. Okay, iterate through it. Now what we're going to do here is we're going to do, okay, so now this p temp dot is full. And if this is false, then great, we have room break. Right, so we found it. So so now it's p temp, and our answer is going to be the case. So p case. Case equals, right. Boom, we found it. Go there. Now, here's the rub. It's going to land in here. It goes, not null, cool. Is it full? Yes, it is full. It is full. Increment to the next one. Next one goes, I'm out of space. So we get to the next line here. No cases available. Add a new one to the end. Right? So where's our end right now? What we have right now is this scenario. Person. Case. This goes to null. Then we have key A and key B, right? And now what we're going to have to do is, this is full, right? There's no space. So we're going to have to now add a new case. Correct this pointer, right? And then return that guy. So when we do that, all right, well, first thing is, what was the last guy we just finished? Well, this iterated to the point and it left and it's now null. So if this falls out, it's a null. So at this point here, we have two scenarios. We have if if P case is not null, success, right? We're done. Done. Else, create a new one, right? Right. So this follow the logic, right? So create a new one. So what do we have to do to create a new one? So now we need to create a new one, right? But here's the catch. We need to add it to the end. So it'd be really nice to have the end pointer. So what is the end pointer? So let's just create a new variable here. Case P last P temp. Then right before we increment it, there's P last. Right. And now we have this. We're done here. We're gonna add one to end. First thing we're gonna do is check the thing. This debug, assert P last. Okay, that's good. So now, and we can also make a second assumption that if it's the last node, it should be pointing to X, should be null as well. And that's just because when we look at the diagram, the green one, if this is the last guy, it should also point to null before we correct it. Okay, cool. All right, so now we go to the next level. Now we got to create one. So case P new case equal case P assert sorry, debug assert P new case not equal to null. Call new should always do assert. All right. All right, so now we got to add it. So add to front, add to the end. So then it becomes P last P next equals P new case. Make sure the P new case is terminated correctly. P next equals null. And now P case equals P new. Right. So save my logic. Boy, you draw some Venn diagram and some of the logic's a lot more complicated. All right, so our logic here is if let's just go from scratch here. If our logic, if this is empty, right? First scenario, this is empty. The person's head is empty, right? That's right here. Person's head's empty. Create one. All right, we create one. Cool. We on the creative one, we create one head, but we should also here p temp dot p next equals null. Just make sure that pointer is null, and then we're going to return it. Okay. So p case is there, and it's going to flow all the way down here. It's going to return the case. Next scenario. We have something complaining, and we might have key A, and then key, this one's empty. So if the next one's empty, it's not full. There's at least one or two empties. If it's not full, set the PKs and leave. If it loops through there, and if it loops through there, and what happens? It doesn't hit this breakpoint. It loops, loops, loops. It captured the last. Since this thing would have aborted this while loop with a break, does not null, we're done, do nothing more. If the case is null, so then right here, we know by definition the case has to be null because this is not null, so this is null. Now what we're going to do is make sure the last one is valid. So is this purple one valid? Yes. And does the next point to null? Yes. That means it's the last guy. Cool. Create a new one. Right now we're going to do the correcto. So here's the last. We created a new one. Right. So we're going to sit there and next now points to the new guy. And the new next goes to 0. And those should be null. We return that. And this is going to all the way here. That condition, and then it's going to return the case. So it's kind of yucky logic, but that's why it's all encapsulated in this private method. So just close it. All right. So now this returns case, and we got lost in the woods. Find an empty case. Go all the way back up here. Now we're gonna ditch all this shit. Fine. Find or create empty case. Find or create empty case, and this becomes p case equals that. And this is technically this function. Okay, now. Now we just do a extra check. Better be empty. Yes. Okay. Then we can sit there and add it into one of these buckets, and then if we hear we messed up. All right. So it's a little bit rough logic there, but compiles. So that's good. Now let's go through here. And this is why the dumps are so cool. So now add a boom, there's the A. We can see A is added, and the other one's empty. Boom. A and B are added. This points to nothing. Then, boom. This A and B are in the first one. Then it goes to the next one. We're going to have to fix the print. Then it's C lands in that one, and the next one's empty. So let's fix this print. So that is case. Case is print. Should be blah, 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 dot get hash code. Well, will this work no matter what? Maybe this conditional is not needed. I don't know what happens when you pass a null to it. We'll see. Yeah, explode. Okay. All right. So and that makes sense. So now the first node, 63, goes to the next node, 63. Next one ends. Seeing this. So now we can rinse and repeat this a couple more times. All right, so here's the first one. Boom. Second one, fill it up. Third one, create one and add C. Next one, fill the D. Next one, create a new one and fill that first slide up. So here we go. We got this part going. Right. So you can kind of see my little approach to this. This is why, to me, the print statements are so useful, because it's like, so here, this is F, right? And then if I wanted to, I can sit there and do this again. I can just put G there, and let's see here, A, B, C, D, E, F, and then G. Next goes to null. The head points here. So on the print statement, so let's go to the person print. Person print, what we should do is right here, debug dot right line. Oops. Get cache. All right, so we can see the first one right here points to the first node, so we can kind of see that node there. And okay, so then we can start to delete it and start following the stuff out here. So questions, issues, does this help at all? I have no clue. I'm just talking to myself.
Yeah, it does help. Can we see the class diagram though? Can we see the class diagram? Quick look. So the person has a head pointing to the case, which is the program orders new cases, right?
Yeah, the person's going to have multiple cases.
Yeah, the program orders the creation of those cases, right? Yeah. Then the what was the question? Sorry, I forgot the question.
Other people questions? Was this helpful?
Yes, Professor.
Yeah, just helpful watching you work.
Yes, it was.
Particularly your use of the dumps.
Oh yeah, just it's weird because to do this, right, you can use a print statement. So let's go look at that. So right here. I mean, you can use a debugger, but it's actually harder. Right. So right here. Now, what I would do is I go watch window. I go, P person. Boom, right? And then you have to do net head, right? Then here's all your keys. Next. Here's all your keys. Next. Here's all your keys. Next. And you would think like, oh my God, I got it all right here. I don't need anything else. Here's all my data, right? Trust me, the print statement is going to make it a lot easier. Because, all right, when you have double linked lists, how do you make sure it goes forward and back? How do you visualize this? Because you can kind of click in, click down, click up, click down, and it starts getting very confusing very quickly. Print statement's like, here it is, right? So now, things we can do to improve this. Now we can take this and write an iterator for this. So instead of me walking this linked list weird thing here in the dump, I can have an iterator that goes dunk, 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 and it just goes walks through all the nodes, right? I can start to separate, I can create add link. That's link. Right, I can start adding an S link and right, and then what I can do is make, then the next factor is, okay, we'll just make it derived from S link. Right, and now get rid of this guy here. And now there's our code, right? So, what do I need to do this? Right, and then the next thing I could do if I wanted to is go into here, person, and say, you know what? I don't point to a case, I point to an S link. Right, and now it points to S link and start to rework it to see what would happen. What is it? And you'll start to see, you want to point your pointer. I think you always want to point your pointer to the base class, right? And we're pulling the link out of here. So inside the code here, I have the attach, right? So here's a function here, add to the front, or add to the head. And I have right here, add to the end. Maybe I would separate those out into functions and then have that function work for me. So you don't need a very complicated problem to start giving yourself a good sandbox. But the catch here is once you get it done, stop patting yourself on the back. The world doesn't care that you got it working. What we need to do is now try different ways to get it working. We got to get out of this mindset. If something compiles and it works, we're proud of it. That's just our first step. Of course it's going to work. Of course it's going to compile. The next thing is we got to now change our architecture and change our layout, change our connections, change our dependency. So don't get too like, oh my God, great, it works. Because if you are that way, you're going to get really upset with this class because we'll be throwing away a lot of code that we did wrong. I think a really big part of what I do that I think is a little different is I draw the boxes first before I do the code. Because if they're not connected right, you're never going to get it right.
So like we document it first, then we write it down.
Well, think about it. If you have these arrows and boxes wrong, I don't care how clever you are coding, you're not going to solve it.
Yeah.
Right. So at least you got to have all the right parts, and you have to have the right parts pointing to the right order. And then if this is wrong, you change it up front before you go into it. Or once you start coding more, and you're like, I had P head, pointing down here to case, and now, oh man, there's so many problems. I'm doing weird casting and other things. Maybe that's my mistake. Then you move it and rework it and see, what will happen is if you're doing it correctly, your code gets cleaner. If you're going down the wrong direction, your code gets uglier. This right here, I think this is sloppy logic. What I did here, from here all the way up, it's a lot of logic. I mean, it's right, but it's a little bit confusing. I would probably rework this into functions in here. Like, is the total list empty? Kick it off to a different function. Okay, list is not empty. Okay, iterate through, find the last one. Cool. Is the last one empty? Yes or no. Full? Yes or no. I would break this down into 3-4 functions. This is hard logic. Logic should be very high level functions. Take care. Find the case. Is it full? I mean, that's better logic because you just follow it. You talk out loud. If it sounds right, you're right. This one should be here. It should be not. It's full. This next one should be. What is this? What is this code doing right here? This code should be insert into empty slot, right? So this should be this. Insert private. No, this would be p case insert key, into empty, right? And you pass in the key. Now all this stuff, poof, goes away. Now look at our logic. Add a key, find an empty one, make sure it's not full, and go in here, right? And then furthermore, this is now full, can probably go inside this key function here. This one can go inside of there. Now your code looks like this. So let's assume I move this function into this insert key. Now your code looks like this. Wow, that's easy to understand. Or at least to me. Your code should be a conversation out loud. When you get into stuff that's this, there's a conversation. I'm kind of making it, but there's a lot of complexity here. And that doesn't feel good. So I would keep adding functions, moving functions, renaming things until it looks pretty clean.
Which is the encapsulation, right?
Right. Mm-hmm.
Mm-hmm. Okay.
Okay. Other questions? Anybody?
Hey,
Is this useful? Do
really
you guys want me to do this every week?
This was really helpful. I know the PDF for Sprint 2 said to check Piazza for the due date for Sprint 2, but
Yeah, that's supposed to be this Sunday.
this Sunday. Okay.
Yeah, just get going on it. I'm you know, I need to grade PA1 and Sprint 1 and finish PA2 and get that out. So I'm not pushing hard on the date, but you gotta, start going because
Yeah.
Sprint 2 is stinking a lot of work because you did no work for Sprint 1. You did nothing for Sprint 1, and Sprint 2 is suddenly four days worth of coding.
Yeah, I heard you there. Okay, I was
Yeah,
just under the
yeah,
assumption I was
yeah.
aiming for Saturday midnight like the previous due date, but I hadn't seen nothing set in stone yet.
Yeah, no, just keep coding. The answer here is it doesn't really matter. I wish I can treat you guys like industry, which is in 10 weeks, I want the final project. That's what I want. But if I do it that way, a lot of people would just keep blowing it off, doing a little bit, and all of a sudden they can't finish. So the sprints are there just kind of push you and keep you motivated.
Good.
Right.
Thank you again.
Cool. All right.
Thank you.
All right, I'm gonna let you guys go, and I
Hey,
don't know.
last night video be going up soon?
Yeah, the video will go up. In that, the question I have for you guys that are here, do you want this video to go up as well?
Yeah.
Yeah, of course.
Okay, I just, because it's office hours, sometimes, I give you guys choice because if don't want to ask a question. The good news, right now, you see this box, it all goes black when it's on the recording or removed. So nobody really knows what's going on.
Yeah, having office hours uploaded would be nice. Like, for example, today I didn't have to go to work, but usually I would be at work and wouldn't be able to attend this. So just being able to see the recording would be really helpful.
Now, this sounds weird, but you can get along with a couple programmers and you can code this stuff together. You can try ideas out. You can bounce things. You can work in, you can set up Zoom sessions yourself, we used to do that when I was in school. We would just all go to the cafeteria and sit at tables and work with each other. So you can do it physically or you can do it virtually. I think there's some value in the community. So if you can do it, great. I also know a lot of people are up at 2, 3 in the morning. You just ping out there who's up there, who's awake. And you can do even live coding sessions on Discord, And I know some people will just set up my other students, my other classes, what they'll do is in Discord, they'll just open up a voice channel and they're all coding at 2 and 11 and 10 p.m. And they just have the voice channel up and they're all talking to each other as they code. That's okay. What you need to do is get in the habit of just coding all the time. And the weird thing is the more you code, the easier it gets. What we just wrote here was pretty complicated and we got it done in an hour. All right, I'm gonna let you guys go and I'll post all these notes and get everything up going. I have 30 minutes before my next office hour. So, all right, thanks.
Thank you. Ed.
Thank you so much.
Thanks.